Now that we've got an overview of the rigid body system, let's look at more detail and specific scenarios. Something that's of big interest lately is the ability to use rigid body dynamics for creating machinery and actually self-propelled type vehicles. And actually the rigid body dynamics and exercise has been used extensively in different car games because it actually excelled at mimicking the physical motion in cars and mechanical type behavior. So that actually makes it its strong point for kind of doing these type of systems. So in this case here, what we've done is built a very simple self-propelled type bug creature with 6 legs, and it's using a variety of hinges and motors to actually achieve the motion. And actually rebuilding the animation of an object or vehicle through rigid body has a lot of advantages. The main thing is you can actually input real world data in. So you can get the mass of different vehicles, of different structures, and actually input them into the rigid body system and get realistic results. And also it's able to react to collisions and forces. So for example, in this case, if we drop a sphere into the scene, we can scale that down and just translate that up slightly, make that an active rigid body. We can play back the same simulation, and without having to adjust anything, we're going to get it reacting to that actual new object. So you can see, obviously, there's a lot of distinct advantages of actually building the animation procedurally through rigid body dynamics rather than keyframing it. Because as soon as you start adding different effects, different collision objects, an animator would have to go in and retune the animation and adjust things to react to these forces, whereas a rigid body just incorporates it automatically. So let's just take a quick look at the scene and how it was actually built.